Hello all, welcome to Leetcode Daily Challenge. Today's problem is sliding puzzle. So in this problem, we are given 2 cross 3 board. There are 5 tiles labeled from 1 to 5 and an empty square represented by 0. A move is considered of choosing 0 and the 4 directionally adjacent number and swapping in. The state of the board is solved if the board looks like 1, 2, 3, 4, 5, 0. Given the puzzle board, return the least number of moves required so that the state of the board is solved. If it is impossible for the state of the board to be solved, return -1. Okay, so this likes the typical mobile game that we play, that we are given this 6 blocks and we have to make them in order 1, 2, 3, 4, 5, and the gap should be at the very last, that is represented as 0. Okay, so in this problem, if you see, if I swap 4 with the empty position, it will be in that order. So this is what it says, that in one move you can swap it and make it to the correct form which is required. Let's see another. In this problem, they have said that it is impossible to make the move, but how do we know that? uh, let's keep on trying, but there should be some sort of something that we need to do, some algorithm that we can apply so that we can be sure that yes, it should be done, because it's not a mobile game that will give a try and eventually land it up there. Okay, so let's see another example. So in this example, here it says the answer is 5. Let's see how. Okay, so the target is that we will try to position one at the very first position. Now if I try to move one down here, 4, the gap will be here, 4 will come there, then gap will be here, 5 will come here, then 1 here, then 1 will go there, then similar something like that. In 5 moves, it says that these are the valid moves. How should I keep track? That is very important, because just because we are getting confused over here. Okay, so what thing we can do is, we know that the starting, this is the starting state, and the ending state will look like something like this. It should be 1, 2, 3, 4, 5, and 0. Empty. Last state should look like this. And we know that from every block, this is my block, I can move to this adjacent, this can be moved down. Two options for very first block. For my second block, I can go left, I can go right, I can go down. Three options. For my this block, I can go left, I can go down. 5, I can go up, I can go right. Fourth, I can go up, right, left. Third, I can go up and left. So I know that if I'm at a particular block, I can move in a fixed number of direction and what are the possible blocks I can go. Okay, so if I'm here, I know this block can be moved above here and here. So if we try recursively, we can find all the possible scenarios where this block will reach in every step. So if I start with here, in my first step, I can position it gap to here, 1 will come here. Otherwise, 3 will come here, or in the third case, 5 will come here. Now, I have 3 different states. Now 0 is here. In that state, 0 can be go here, 0 can go here, even it can come down. Similarly, if 5 was replaced, 0 can go up. In that case, it can come back to its original position. If 3 was replaced, it can go to 2, it can come back. So yeah, that is the overall idea. But how do we keep track of like where it is going and what are the possible strings that are being formed? Okay, to start with, to keep track that how one particular string is mapped to another string, for that I can use some sort of mapping, that I know in one string what are the possible changes it can be introduced. Okay, so this is the earlier solution on the left hand side. If you see, we'll focus here first, that what I did is basically I took a string s, I iterated over my board, and I pushed back my uh, all the characters in a string I made from 2D to 1D. Now I call this recursive function and passed string to s. Okay, first we'll understand this recursive function, then we'll move to the rest of the solution. So what recursive solution was doing, just what I said, that currently I created this G is my graph, which is basically map. This is a first is a string and it is mapping to a set. Set is all the possible different strings that can be found by tweaking the position of the dash. And map visited is basically where the maps will be, whether that element contained in a map or not. So for that it is, we could remove that, we does not necessarily need this visited array, but it was a very first draft, so we can edit it, and in the finally solution where we landed, we can see that it's not present there. So this was very first draft. So yeah, what I did here is that I'm looking for the position of z 0, where zero is present. So z basically located where the position of 0 is, and I'm checking that if position of 0 is 0, and accordingly, as I stated here, that if gap is here, I can move right and down. So similarly, what it is doing is, let's go and check. First, swap 0 with 1, the possible positions, and then in the map of g of s, go, which will basically a set, go and find if this current string is present or not. Current string is basically the string which is coming as a function which is being passed, that is current, and after swapping the string will be s. So find that if in s is this present or not. If it is present, not present, then simply add it to there. So this is how my graph will be formed, and call the recursive function, because you have to continue doing that so that you have keep track like what are the different possible ways or possible strings you can get. Similarly, I will come back to my original string. Now try with another path, that is going down. Again, I will check the same thing, and again I will swap it back to move it to original position. Similarly, I will do for every index. So 1, I have 3. For 2, again I have 2 options. For 3, I have 2 options. For 4, I have again 3 options, and for 5, I have 2 options again. So this is how I'm recursively calling every stuff and keeping track of how it will map. Okay, so here we are done. Now our goal is that we should reach to this state, which is target state, in minimum possible number of moves. Okay, minimum possible number of moves. Since this looks like that we are forming a graph, can we use BFS traversal here? Yes. So we are using BFS traversal over here, creating a queue where I will be pushing back my string, and a map of answer where it will be stored, like what is the current minimum distance or minimum moves to reach that particular target. Okay, so I have first initialized my answer s with 0. Then what I did is basically this is my target. Have I mentioned? No, I have not mentioned. Yeah, so target is basically 1 2 3 4 5 0. This is how my finally where I have to reach. I will continue my BFS traversal. I will go, I will pop the very front element. I will check in that element that iterate over all the adjacency set. Basically in this we have adjacency set. So do check that if it is present in answer or not. If it is present, that we have already covered that string in minimum moves, so we don't need that. If it is not, just update my answer of 5 with the x plus 1, because in I have reached a distance d for my x. So in x d plus 1 will be my the distance for I. So I will push that back to q in the I. And finally I will check that if my answer contains target or not. If it does not contain, my answer is -1, because it cannot be reached. Otherwise what we'll do is we will simply return whatever the answer of target was. So yeah, that was the very first draft that I did. So it contains a lot of redundant code and recursively calling all that stuff, which can be reduced. Okay, so I hope you understand the BFS solution which we are targeting here and we are trying to achieve. If you have any query, do comment it out. I will try to resolve that. Okay, so now the finally updated and finally a crisp code. Now I have created a string s here, and target is, as I said, it will be 1 2 3 4 5 0. S will be the original state. So here in s I am storing, iterating over the board and storing it from 2D to 1D. Now instead of going recursively, I mark down my moves, that if I am at 0, I can go to 1 and 3. If I am at 1, I can go to 1 0, I can go to 0 2 and 4. 1 0 2 and 4. If I am at 0, I can go to 1 and 3. Similarly, I have mapped all the position, that for this position what is the required number of swaps that was required in the recursive solution. So that I have done here. I have created a queue. Now my queue is of string and integer. Now string will basically represent it, that for this string an integer will be the number of moves required to move that up to that string from the original state. An unordered set I have created, which is basically marking for the visited or not. For initially I have used the initial string and the distance is 0. Inside the visited I have marked that insert the starting string. Now again a BFS traversal, I will store my current set of string and the steps required there. I will pop the front element. I will look that if my current matches target or not. If it matches, simply return the steps. Otherwise, you continue. Now, zero pause is basically find the first location of the zero, where the zero is. So there's only one zero, so I will find that position. And now I will go to moves of 5. Moves of 5 will tell me what are the different possible moves that I can go to in order to avoid that recursive part. This is how we are doing it. So I have the move now. So I will swap my next of the zero, where the zeroth position is, with the move part. It is being swapped, and I will check that visited of next, the element that is formed, it has that number or not. So if the next element, which is the updated string after the swap, if it is in the visited set or not. If it is not visited, then you go there to insert it and also add it to the queue with the steps plus one. So in this BFS setup, if I'm anywhere reaching the target, it will return the minimum number of steps. Otherwise, I will be turning -1. So yeah, that was all for this question. This was simply how we will form the graph. That was important, and we have to apply a graph. That was the very important step in this problem. And finally, BFS traversal is all we need. Some of these manual tasks, that how we are going to some implementation, that all we need. So yeah, that was all in this problem. If you understand the problem, give it hit a like button and do subscribe for more daily content. If you have any query, do comment it out. I will be happy to resolve it. So thank you guys.